Welcome to this Educast presentation, Session Border Controllers for More Than Security. We have a lot to go through today, so let's talk about what you're going to learn during this Educast. First of all, we're going to discuss what is a Session Border Controller so we all start off on the same footing. Why did it become necessary to have an SBC, Session Border Controller? There's a difference between the Session Border Controller of the provider and of the enterprise. We're going to focus on the enterprise Session Border Controllers. You will know that SBCs have become necessary for connection to SIP trunks. We'll discuss a lot of the SIP trunking issues then. But one thing you don't know about is how an SBC can help you with business continuity for disaster recovery. We'll introduce the subject of WebRTC and how it affects the SBC, and we'll also discuss the standards that are appropriate to work with a Session Border Controller. There'll be two of us speaking today. I'm Gary Auden, President of Delphi Incorporated, and with me is Frederick Dickey, Vice President of Professional Services and Product Management at Sangoma Technologies. And let's start off with the first question. Frederick, would you help us understand what a Session Border Controller is?
Okay, so we have kind of a standard definition here. A Session Border Controller is a dedicated hardware device or a software application that can run in any type of servers. And what it does is it governs the way in which phone calls get to connect between various voice over IP networks. Okay, so if I read it off directly, are initiated, conducted, and terminated over a voice over IP network.
Now, a lot of people think that the SBC just started with security. Is that correct?
Yeah, where it started with was the SIP protocol. As it became more and more prevalent, one of its issues with SIP is that it does not traverse NAT, network address translation functions that you find everywhere in the internet. And where this manifested, the first was with service providers that wanted to offer, a PBX, like hosted PBX service, or sometimes called SIP Centrex, or sometimes called, SIP dial tone. And what happened was, customers with a voice over IP phone that was sitting inside their enterprise was behind this little, router broadband device that everybody has, could be just like a Linksys router. And the NAT function that allows the translation of private and IP address breaks end-to-end communication. And the only way to break that, to allow end-to-end transparent communication, is to open up the firewall. But if you open up the firewall, you end up with all kinds of security issues, not only for the voice over IP network, but also for your existing data network. So initially, SBCs were brought in to allow end-to-end communication without having to change your firewall. That's basically why, why SBCs got started.
Now, we look at an SBC and we look at its layout. Can you talk about the deployment of the SBC? Where does it fit between the customer and the network?
Yeah. So this is the typical example how it kind of started. If you move from, I'm going to go right to left here, is a service provider in their network, in their cloud, they will have something like a soft switch, you will have all the customer accounts. They will have interconnection agreements, with other service providers. But downstream from that cloud, how to reach your end users. Here I'm showing a number of voice over IP phones sitting in an enterprise behind this little, puck or arrows that does, anybody that has a cable modem or a DSL modem, all these functions, everybody has this at home or in their business. So what happens is you need an SBC from the service provider point of view to provide not only security for the service provider network, but also to be able to reach out to all these SIP phones in a manner that is transparent, to be able to receive and make calls for these voice over IP phones without having to remove that firewall function at the customer. So typically, when you get a service like that and you set up a voice over IP phone, the telco will tell you to program your phone to hit their SBC, and then the SBC will do all the admission control and all the security relative to voice over IP before your call and your service can ramp on to their service provider network.
But I have an issue here. This is an SBC for the service provider. Why do we now need an enterprise service provider? Why did it start with just providers?
The way voice over IP penetrated the networks was like voice over IP islands. So the first ones to really implement voice over IP were carriers on their toll networks between carriers. Then it moved to these alternate ISPs that would offer what I just described on the slide before, like SIP dial tone. And then another island was Enterprise deploying an IP-PBX, but still connecting with TDM. So you had these pockets of voice over IP that were in and of themselves were really good and serving, these various markets properly. Now what's happening is voice over IP is so prevalent that now you're seeing you need to link all these pockets together, and now you're really having voice over IP end-to-end. So now that you have an enterprise with a voice over IP PBX that wants to connect to a SIP trunk that in turn will connect to the service provider network, now we're having end-to-end voice over IP, no more switching back and forth. And now by doing this, you open up the same issues that the service provider had, way back when. Now you open up the same security issues for the enterprise.
This is all to go over SIP trunks. Can you talk more about that, please?
So a SIP trunk, a trunk is like this old telecom term that has been in use, for a lot of people think about trunks like a T1, a connection between your PBX and the phone company. So a SIP trunk is a similar offering than your good old ISDN PRI, but is done over a broadband connection. So from your enterprise network, you're reaching out to your service provider by using either like a managed voice over IP, a managed data network, or you're using the internet. And now suddenly, just because you are using SIP trunks, which are very useful, for price-wise, cost-wise, it makes it much easier to manage than good old T1s, but comes with that like a different set of challenges which are security related. So that's what a SIP trunk is more like a concept. It's a service concept that equates to what enterprise users were used to get with their good old T1 service.
So that brings us to the Enterprise SBC, which you started to talk about, but why do we need that if the carrier already has one?
Yeah, so the carrier has one. He uses it to protect his own IP network. When you get to your enterprise voice over IP network, and now you open it up to a SIP trunk, to another voice over IP network, you start to need to do the same thing. So you need to protect yourself from unwanted or bad people coming in over, let's say if you're using the internet, you now have to protect yourself against those threats. Okay?
So there are some best practices. I'm sure that you've developed best practices over the years for dealing with enterprise SBCs and the carrier SBC.
Yeah. So as a rule of thumb, if you talk to any IT manager, right, so people that are not coming from the telecom world but coming from the IT world, their rule of thumb is every time my IP network touches an untrusted network, a foreign network, I put a firewall. Okay? I need to protect my data network. And what happens when you get to voice over IP end-to-end, like in this case I'm showing, in this case there's absolutely no TDM at all. I go from a voice over IP phone that hits an IP-PBX, that hits an SBC, a SIP trunk, an SBC at the carrier, and a soft switch. Okay, so every time I leave my trusted network, in data world, they would put firewalls to secure their network. In voice over IP, you need to put what I call sometimes the voice over IP firewall, which is what the SBC does. So in this picture, at the edge of foreign networks, so when the carrier leaves its network to go to the IP cloud, SBC is there. when the enterprise network, which is shown by the IP-PBX and the phone, leaves towards this IP cloud, I put an SBC. So that's kind of a rule of thumb, and the practice is very similar to what data guys have been doing for years in installing firewalls in their networks.
Now, there are a lot of standards out there. They all come from the Internet Engineering Task Force. What standards are important here in the SBC world?
Yeah, so we talked up to now a lot about security, right? Everything is about security for the SBC, but there's a lot of other things that SBCs can perform because they are situated at the edge of the network. You know, like a firewall, you put that at the demarc between yourself and somebody else's network. So being in such a central place, it can also become something that performs a lot of other roles in security. So one of them, that was another challenge with introduction of SIP. Okay? SIP became very popular, you know, early 2000, and one of the issues was, you know, RFCs are not super tight specs like the ITU. So there are more recommendations. So even if, you know, an engineer from a company that makes a phone and an engineer that makes a gateway from another company, they might all follow the SIP reference, SIP standards, but in the end, my SIP doesn't talk to some other vendor's SIP. So one of the challenges early on was this interrupt issue. So because you have many choices in SIP, as an engineer, you can make all kinds of decisions, and one illustration we have here is that words like should, can, may, option show up a lot in the RFC documents, which suggests, you know, you have interpretations, you can make decisions while still meeting those requirements, but doesn't mean your equipment, your SIP equipment talks to the other SIP equipment. So instead of figuring out everything between every single vendor, SBCs started providing this kind of interrupt, you know, having the SIP version from company A talk to the SIP version from company B. So that's another thing that SBCs are doing, you know, to harmonize the differences that may exist on both sides of its connection.
So that brings up the word transcoding, which not everyone knows about, but what does that mean within the SBC device?
Yeah, so as with the SIP provides a lot of choices for voice over IP engineers that design their voice over IP network, they have a lot of choices in how you encode the voice. So as you digitize the voice, you can use codecs to reduce the amount of bandwidth that is required to transport those voice over IP bits. Okay, so G711 is the equivalent of today's phone network in 64 kilobits per second, but there's all kinds of codecs that exist out there that could allow you, you know, if you use G729, for instance, which is very popular, you can reduce 8 to 1 the amount of space that's required. So if you are doing international traffic, you know, bandwidth might be expensive, so you may want to compress the voice. If you're using G722.1, which is a wideband codec, so it sounds like HD voice, you might want to use this inside your enterprise because bandwidth is not so much of an issue. But the problem is, again, when you connect network A and network B, and the two, you know, the network engineers on each side decided to standardize on a different codec, then you can't have end-to-end calls, right? So again, because the SBC is in the middle at the edge, you can use it to, on the fly, constantly change the codecs to make it look like a, you know, end-to-end call without any hiccups. So that's one of the role of interrupt, you know, to harmonize differences between networks. That's another role that the SBC can do, perform transcoding.
But I'd like to change the focus now, and something a lot of people don't talk about is how the Enterprise SBC can help in business continuity and disaster recovery.
Yeah, so an SBC, because, again, sitting at the edge, can perform a lot of functions that are relative to business continuity. So, for instance, I could subscribe to multiple SIP trunking providers. Maybe as an enterprise, or I have a call center, and I want to take advantage of better rates from certain service providers, maybe during the weekend or the evening or whatever. So I can build that sort of routing intelligence in the SBC to select the least cost of routing, or if I fail, if one of my service provider fails for some reason, then I can divert traffic to another service provider. Very easy to do in SBC. In the days of T1s, not so easy. You have to have these T1s sit there and kind of pre-provision. So here, very easy to do. Another one, which I see a lot between customers that transition between legacy PBX and unified communication technologies like Microsoft Link, for instance, they will use SBCs to facilitate the transition. So you might want to flip a routing rule in the evening to test all your calls to your new UC technologies. In the morning, flip back to the old PBX until you are ready to make that switch over. So those are, transitioning or business continuity. Those are also very applicable scenarios to session border controllers.
We've heard a lot about WebRTC. Some of it's hype, some of it's real, but the WebRTC function has to pass through the SBC. Could you focus on that for a minute?
Yeah, so at some point, right, like WebRTC, when I mentioned SIP was kind of coming of age in the early 2000s, now we're kind of, I can see, I guess I'm old enough to see the discussions around SIP back then and the discussions about WebRTC now, very similar. So at some point you'll have a great chunk of people on SIP, and you're going to have more and more people on WebRTC, and there's going to be a need to interoperate, just like you needed voice over IP gateways that did SIP voice over IP to TDM, SBCs that harmonize between different variations of SIP, and now it's just a natural extension for an SBC to allow interoperability between WebRTC end users and SIP. And so WebRTC, is just a natural extension of what SBCs are going to support.
So Sangoma's in this market. Would you talk about your position in the SBC market?
Yeah, so Sangoma comes from the small and medium enterprise. We've always been a quality and value player, so it's the same for our SBC products. While I say this, we also work with Tier 3 service providers typically. So the way we've positioned our SBC is it ranges from all the way down to enterprise users at the 20 some odd session count, and we can grow all the way up to 4,000 sessions. And it is very easy for our customers, that migrate between these markets to use our SBCs, because it's the same, for us it's the same software, it's the same look and feel. Any trade people or technicians that get trained on our box will recognize the same product end to end, whether you play with it on the enterprise or in the carrier space.
For those of you still listening, here are some resources to go to learn more about SBCs and more about Sangoma within this market. And we're going to provide you some contact information here to get to Sangoma and find out more about their products and the SBCs. So I thank you very much, Frederick, and I appreciate the time you spent with us.
Thank you very much. Pleasure.